Any description of the origin of the universe is a hypothesis, not empirical science. But we can look for such a hypothesis about the origin of the universe, which is consistent with school knowledge of physics. Let's begin the presentation of the origin of matter by looking at electric and magnetic fields. An example of their connection is EM waves in the form of light. Both fields also enable other forms of their interweaving. Even the random bubbling of electric and magnetic fields is a form of their interweaving. Despite being chaotic, this EM disturbance occurs according to the laws of electromagnetism. In EM bubbling, a ring of magnetic field can appear. Such a ring is not permanent. A force acting on the magnetic field reduces the size of the ring. Let's illustrate the phenomenon. An external force F keeps the magnetic anchors at a distance. Both the external force F and the equally strong attractive force of the magnetic field act in the space between the two anchors. If we remove the external force, the force of the magnetic field attracts the poles. In the same way, the size of the magnetic ring, which is formed as a result of electromagnetic bubbling, decreases. As the magnetic field shrinks the loop, it creates an electric field in its place. The magnetic field weakens, and the electric field strengthens. An electric field also creates a force, but in the opposite direction to a magnetic field. The force of the electric field tends to expand the EM ring. Random pulsations of electric and magnetic fields are non-persistent. Such electromagnetic rings are formed, collide with each other, transform, and disintegrate in the process. The model of the distribution of the electric and magnetic fields in the ring shows the magnetic field in blue and the electric field in red. The arrows on the left show the directions of the fields. The EM ring contains another form of field, which is called displacement current. It is created by electric and magnetic fields in the direction of the pointing vector. The displacement current connects the electric and magnetic fields. The direction of the displacement current in the EM ring is shown by the dashed circle. EM fields can oscillate or wave. The oscillation of an EM ring is different from a light EM wave. In a light wave, the electric and magnetic fields appear and disappear at the same time. When the EM ring oscillates, the electric field transfers into the magnetic field and vice versa. The description of the oscillations of the EM ring is not complete if we do not describe the energies. The energy of the electric field is proportional to the square of the electric field strength, and the magnetic field energy is proportional to the square of the magnetic field strength. But here we face a surprise. Magnetic field energy has negative energy values. Positive forms of energy are capable of doing work. The sun warms us. Steam drives machines. Negative, or binding energy, connects. For example, binding energy binds an electron into an atomic shell. A photon can knock an electron out of an atom. The positive energy of the photon and the negative binding energy of the electron cancel each other out. Their sum is equal to 0. Sometimes, not always, we are free to choose the 0 state of energy. This liberty is not possible in the case of oscillation of the EM ring. A field has 0 energy when there is no field, when its density is 0. Then, the curve goes horizontal. When there is no field, there is no energy. When an electric field appears, this is reflected in an increase in energy in the positive direction. However, when a magnetic field appears, this is reflected in an increase in energy in the direction of negative energy values. Something else is missing. The energy of the EM ring must be the same all the time, despite the waves. To ensure that this condition is also fulfilled, we add the already mentioned displacement current energy to the diagram. Like the electric and magnetic fields, the displacement current also exerts a force on the EM ring. When the displacement current tries to expand the ring with a force, then the energy of the displacement current has positive values. However, when the energy of the displacement current acts in the direction of contraction of the EM ring, its energy is expressed as negative energy. In the diagram, positive and negative forms of energy appear, so that their sum at any moment is equal to 0. Such an EM ring can therefore appear and be maintained without a starting energy. We focus our attention on the oscillation phase, when the magnetic field of the EM ring decreases and is already weaker than the electric field. The attractive force of the magnetic field is weaker than the repulsive force of the electric field. However, despite the dominant repulsive force, the ring is still shrinking. In addition to the force of the electric and magnetic fields, the force of the displacement current also acts on the ring. The displacement current makes the EM ring shrink further until the magnetic field disappears completely. In mechanics, this phenomenon is known as the inertia of a system, the system's resistance to changes in motion. With this contraction of the ring, we recognize that the moving current creates mass in the EM ring. Such EM rings can oscillate in several ways. Oscillation modes mean different permanencies of the EM ring. Let's look at the oscillation where the total energy of the EM ring is not equal to 0, where it is less than 0. This is an oscillation where the force of the magnetic field is stronger than the force of the electric field. With the dominance of the attractive force, the EM ring changes shape. The ring changes into a tube shape. The EM tube is also not stable. Its shape changes depending on external influences. With randomly correct dimensions of the tube, the moving current bends it and creates a torus from it. Just as an electron breaks into an atomic shell and emits a photon, an EM tube collapses into a torus, emitting excess energy in the form of a photon. The torus goes into a state of captivity to itself. In the torus, the displacement current oscillates in the form of a standing wave. The length of the standing wave determines the size of the torus. The standing wave in this way assigns a quantum size to the torus. For a better idea, let's look at a metaphor for the creation of a torus. I imagine the EM ring as a hexagon that is magnetized. In a zero-gravity vacuum, hexagons randomly bump into each other. When they meet, the magnetic field can connect them to each other. At the next collision, these links are blown apart or reformed. However, if the shown connection of 6 particles is randomly established, such a connection is stable and not sensitive to external influences. Let's go back to the torus. A torus has the properties of a particle. It can rest in place. The displacement gives it mass, and it has a certain volume. Toruses combine into the basic particles we know, such as electrons, protons, and atoms. This is described in more detail in the booklet Journey to the Center of the Atom. Toruses, and consequently atoms, are constantly being formed throughout the universe. Toruses and all other particles of matter contain a lot of positive as well as negative energy. Matter is slightly dominated by negative energy. If we add the observed positive forms of energy, such as radiation, to the energy contained in the matter of the universe, we can estimate that the total energy of the universe is equal to 0. The universe contains unimaginable amounts of positive energy and an equal amount of negative binding energy. The universe, on the other hand, did not need a material basis for its creation. It was created from empty space.